Hello everyone and welcome to a webinar about light gauge steel framing in Revit. I'm your host Andres. I'm a BIM application engineer at aga-cad and I'm also a certified Autodesk Revit professional. Before joining aga-cad, I had an opportunity to work on residential and commercial projects as an architect in London for nearly 4 years. During this period in my career, I gained technical design and on-site experience for different types of construction, including masonry, prefabricated timber panels, and light gauge steel framing. aga-cad is an authorized Autodesk developer and a member of the group Archons. We create solutions for continual BIM acceleration, ensuring that clients can finish their projects on time, on budget, at the highest quality standards, and with minimal waste. That means greater profit, saved time, less stress, and reduced carbon footprint for BIM users. Our experienced, qualified, and skilled BIM professionals provide a top quality support, ensuring that our clients meet their goals and objectives. We developed our first Revit add-on back in 2008. aga-cad is valued for high-quality products and strong attention to clients' needs. We work closely with clients to customize and further enhance our BIM solutions. As a result, our clients can save more time, money, and minimize waste. Over many years, we have developed the widest range of BIM solutions for Revit professionals, including precast concrete design, MEP system design, wood framing, and metal framing, which we are going to explore today. We are going to cover the metal framing software concept and workflow. We will look at how to create and update wall frame, how to split parts for sheeting layouts, then number elements, and then we will create shop drawings and schedules. So let's continue our webinar into the live demo. AEC professionals in the light gauge steel framing industry face constant pressure to deliver drawings and schedules on time. Modeling and updating a frame in Revit manually results in hours of additional work, human errors, and wasted materials. Thankfully, we have the metal framing solution. For example, if we select these walls here, with just a click of one button, I can frame these walls. Now our add-on is increasing your productivity. It's minimizing mistakes, reducing waste by automatically placing framing elements in wall type layers according to predefined framing configurations. If you need to frame other building parts, for example, floors, roofs, or truss systems, no problem. We have covered this. For example, here I'm framing floors, and as you can see, the same principles apply. We just have to select our elements and click Frame Floor or Frame Wall button. So, get your 2-week metal framing trial for free now. Visit our website aga-cad.com and download the Tools for BIM doc for free, where you can access and manage aga-cad tools. So now let's proceed with the concept of the metal framing add-in. As you can see, we have 3 different profile types. For example, firstly, we have C+C _ CH frame. Then we have C+C frame, and finally C+U frame. So the first 2 letters stand for the stud and for plate profile. So for example, we have C profile studs and C profile plates. CH stands for chamfered, and this particularly refers to chamfered ends on diagonal elements. Also, if you notice, the C stud cuts through the lips of the plate. In the meantime, C+C frame doesn't include diagonal elements with chamfered ends. Also, the stud families are different because they don't cut through plates. And finally, we have C+U frame. This includes the U track and the C stud. These are the three profile types that come with the add-in. However, if you need to use different profiles, that's not a problem. The families can be easily modified. For example, here we have a U profile stud, then fixed length studs, box stud profiles, and L angles, and so on and so forth. So now that we have covered the concept, I want to highlight that these families, when they are being placed, they are being automated. In other words, what our add-in does is it automates manual Revit tasks so that you wouldn't need to waste your time. It doesn't create any non-native Revit things. All these families are Revit families. So now let's look at the workflow, and we have a few diagrams here. So the very first stage is going to be to load the framing families that we have just looked at. Then we're going to link walls. Like in particular, we're going to link wall types with the framing configurations. And then we will proceed with the standard workflow. From left to right, we're going to frame walls, then we're going to split parts to create sheathing layouts for OSB boards and gypsum wall boards. Then we're going to number our walls, framing elements, and parts. And finally, we're going to create frame and assembly. So let's switch to our window here. You can find metal framing add-ins here in the T4R metal framing panel in Revit Ribbon. You can drag and drop your add-in onto the main view here. And the workflow that I'm going to explain to you right now is the same as for floor and roof add-ins. So as I mentioned before, first we need to load our families. And we have this little dialog, and we have a few options. So as you can see, the box is already ticked for main families, and main families mean the main studs, plates, and so on. Then we have sample details. These are optional. If you want to increase the level of detail for your project, you can load angles and bolts and so on. Then we have sample schedules. These are already prepared schedules with fields and sorting and filters and formatting already in place. Then we have sample tags and split families for panels. We can also load in your own families. For example, if you have modified some of our families or created your own ones, you can easily load them from your computer. So as I've probably mentioned you already, families are already loaded, but just to show you how the process works, I'm going to load them again. Only main families this time. As you can see, the families are automatically being loaded. You don't need to manually drag and drop into the project. This saves you a lot of time. Okay, so now that we have loaded our families, the next bit is to link wall type layers with framing configurations. However, before we do that, I want to highlight the importance of the wall type structure. First of all, you can have as many layers as you need. There are no limits. For instance, right now we have only one light gauge steel framing layer, and it's the main structural layer. But for example, if you have two stud layers, or you have, let's say, two stud layers plus an additional secondary frame for ventilated facades, that's not a problem. You can have as many as you need. You can also have two sheeting layers on both sides. You can easily control the number of layers that you need in your project. So the crucial things are these two tabs. So the function of the wall type layer and the material, we must assign these functions correctly, and each layer must contain a material, because if we don't add the material, walls will not be framed properly. So once this is sorted, we can go into link wall dialog. And on the left, we have a browser with all the wall types in our project. And here we already have selected this wall, so it recognizes the type and it recognizes the name and the wall type layers that we have just looked in the wall type properties. And so the first step is to choose the frame layer. So what's the purpose of each layer? So the structure layer is going to be frame, so we're going to pick frame. If, let's say, you have another frame layer that is for substructure of ventilated facades, you would need to choose secondary frame, but that's a topic for another time. Now for board layers, for example, for engineered woods or gypsum wall boards, for instance, you would normally choose sheeting. And then once we have assigned the purpose of each layer, we need to assign the configuration. So since this is the layer that is going to include framing elements, we're going to choose framing configuration. And we have several framing configurations. These are default configurations. You can create new ones, modify them, rename them, and so on. But I will show you this a bit later. So we picked C+U standard. And since these are sheeting layers, we're going to pick the predefined sheeting configuration, which is also the default configuration, which you can modify and change easily. So after my layers are assigned and configurations are in place, I make sure that I tick this box for framing layer and these two boxes for sheeting layers. Press OK. And all I need to do right now is to select my walls and click this frame wall button. And as you can see, the frame is being automatically placed into wall instances. Again, you don't need to waste your time on manually adjusting the frame, and that's how you save a lot of time. Now, I want you to pay attention to some configuration aspects. So for instance, if you notice, the narrower window has a different header compared to the wider window. That's because configurations for openings vary according to the opening width. And if I go to my floor plan, if I zoom in here, you will notice that I have this specific layout of my studs. And the same applies to different wall joints and wall ends. So I can go to framing configurations now. For instance, I can access them through this configs menu here or under frame wall. And as you can see, we have this dialog. We can break it down into 3 different areas. So at the top, we can choose the frame time. You remember when I was mentioning about the frame and the secondary frame. So each configuration type has its own configurations, and you can save those configurations. You can create your own ones, rename them, or delete them if you don't need them. And then on the left-hand side, we have a browser with different configuration settings. And then each setting contains tabs at the top with the custom join and symbolic preview, where you can apply the families and control their positions. So at the top we have common settings. These are the general settings. And then we have wall framing, where you can modify settings for vertical studs, top and bottom plates. Then we have opening framing. So as I already said, for example, if you include openings in structural walls, like we did, windows that are narrower than 1600 millimeters would have this configuration, and windows that are wider than 1600 millimeters will have this configuration. By the way, if you are using the Imperial system, we also have a version for Imperial system. And if we're talking about the wall joints, then we have 4 different settings. We have L connections, N connections, V and T connections. And in addition, we have ridge stud, blocking, and nogging. So we are currently using this blocking nogging option. As you can see, we have the strap family on both sides of the frame. I can turn off these families. And finally, we have a few more options for secondary stud, brace, and stud holes. So after I made some changes, I need to click the Save button. And now I will update the frame using update by wall link command. And as you can see, the frame is being automatically updated. Again, I don't need to spend my time manually tweaking the framing elements. Also, for example, if I need to move this door and my wall height changes, let's say it becomes lower and longer, it would take me a lot of time to manually push and pull these frame elements. What I can simply do is pick this wall and click here on the Update Frame button. And the wall frame adapts to the new wall shape. And if I don't need these frame elements, I can simply click Delete Frame. In addition, if, for example, I need to add a blocking in between these 2 elements or a stud, I can go ahead and click on this feature called Add Modify Elements, where I have this new menu here, and we're going to add a blocking element between these 2 studs. So all I need to do is click this button, pick one stud, then the second stud, and I have this menu. And here I can control the position of the track element. And also I can control offsets from bottom or from top if I choose so. For example, I can change my offset to 800 millimeters. And then I can have 2 elements that are spaced at 600 millimeters, 610 millimeters, which is just above 2 feet. Click OK. As you can see, we've just added 2 blocking elements according to our predefined settings. I can also modify these elements or delete them. Also, I can add bracing elements. So, for example, if I choose striping bracing, let's say I start at the bottom here near the stud, and I will continue my brace up to this stud. As you can see, we have a bracing element. I can repeat the same here. And then I click on the plate again. And now we have just formed the X bracing. And if you need to increase the level of detail in your project, we can add some structural connection families like angle brackets, bolts. So what I'll do is I will go here, click Add Modify Details, and then click Add Details, select the wall that I want to add those details to. I can select any element. Then I need to choose the appropriate configuration. Click Add Details. And as you can see, the details have been added automatically into the wall frame. So now that we have covered the framing bit, we can move on and create sheeting layouts by splitting Revit parts. So if I change my part visibility, as you can see right now, we have some parts, but they are not divided into boards like we would like to. If you remember, in our link wall dialog for this wall, we linked the gypsum wall board and OSB layer with sheeting configurations. And you can find sheeting configurations here. We also have paneling configurations if, let's say, you're using insulation boards in between studs or facade panels on the exterior. You would normally use paneling configurations. But for situations like we have today, we are using sheeting. All I need to do now is basically select any element in this wall and then click Split Parts. And as you can see, the parts have been split to our predefined configurations. Just like any configurations, these are flexible. If you want to, for example, split your sheeting horizontally, you can easily do that. Right now, as you can see, parts are split vertically. Okay, and we're almost ready to create our assembly, but there is one more crucial step to take. So we need to number our elements. So firstly, we need to number our walls because assembly is numbered after the wall mark instance parameter. So I will click number walls and the wall parameters have been filled. I will do the same for number elements, and by elements, I mean framing elements and structural connection details. So each element will now have values added into specific parameters. And I'll do the same for parts. Just need to click number parts. So after our elements and parts have been numbered, we can be assured that once we create our assemblies, the tags for framing elements and for parts will be filled. And I will turn the part visibility to show original. You may or may not know this, but you can create assemblies in Revit manually. For example, if I select these elements, the wall, and then I click Create Assembly, you can see that I need to manually name my wall assembly. I don't know exactly what name would it be because it probably doesn't match the mark instance parameter in the wall. I click OK, then I can see that I've missed some elements, so this becomes frustrating. I need to edit my assembly, and for example, if I need to create views, I would need to go here and tick those views that I need to see in my assembly, and then I would need to place them manually into sheets. I want to avoid that. I want to save time. So I will go back a step. So what we will do with this button, in particular what this button does, basically not only it creates an assembly, but it also creates views and places dimensions on elements, it places tags, and then allocates each view into sheets. You can control views in drawing configuration settings, and the layout of views in the sheet will be displayed according to the existing assembly template. So for example, we have an existing wall assembly here in our project where we have 3 different sheets with views and schedules. Once we create the assembly for our framed wall, the layout is going to be practically the same because our new assembly will use W4 wall as a template. So as you can see, that now the assembly is being created, the views are being generated, dimensions are being placed automatically along with tags, and those views are automatically placed along with schedules into sheets. So as you can see right now in the project browser, under assemblies, we have a new assembly. and we can go through sheets. As you can see, we have a new assembly with its own schedules, its own views, and the layouts are identical to the wall that we have looked just a couple of minutes ago. So it's all automated. Dimensions are there, the tags are there, the schedules are there. You just saved a ton of time. And now the last step of this presentation. Once we have our walls framed and numbered, we can also export the model data for CNC machines. So we have an add-in called CNC Metal Exporter. So if I open the menu, as you can see, I can set the default CNC type. For example, right now I'm using Howick, but if you need, you can switch to Pinnacle, to Metrol, Royal, AMS, and ScotSim. I can also prepare export, setup, calculate number of screws for walls, floors, and other element types. So let's export wall frames into a separate CSV file. So I just need to select any element from this wall. And a document has just been generated. The folder is here. As you can see, it was just created. And if I open it, you'll find all the data that you need for your CNC machine of the wall frame that we created during this session. So our live demo is over. And here are our conclusions. So the metal framing saves hours and eliminates human error. It automates Revit tasks using various configurations. Light-gauge steel framing families come with different profiles and sizes. Framing detail level can be flexible. And software automatically frames all framing elements and openings. And of course, sheeting and paneling layouts, element numbering, and shop drawings are also automated. So visit our website at aga-cad.com and start your free trial for 14 days now. Contact us at info@aga-cad.com. I'm your host, Andrus, and thank you very much for watching.
aga-cad, building BIM together.